In problems 9 through 12, you are to find the trigonometric ratios for angles A and B. Side AB will be the hypotenuse, no matter what problem you are doing. In sine A, you are to find opposite over hypotenuse. I labeled A orange, so the opposite of angle A is going to be side CB, which is 14. And the hypotenuse again will be side AB, which is 22. This reduces down to 7 over 11. In number 10, tangent is opposite over adjacent. So the opposite side of angle B, labeled blue, is 18. The adjacent side is 14, reducing down to 9 over 7. In number 11, you are to find the cosine of B. Cosine is adjacent over hypotenuse. The adjacent of side B is 14 and the hypotenuse again is 22. This reduces down to 7 over 11. In number 12, you are to find tangent, which is opposite over adjacent of angle A. The opposite side of angle A is 14 and the adjacent side of A is 18. This reduces down to 7. The first thing to do in this problem is draw your right angle. Label the angles A, B, and C, and then label what we know. We know that the hypotenuse is 13 and the opposite side of theta is 5. Since angle B is the right angle, then angle A and angle C are complementary. Remember that angle C is equal to theta. This means that 90 minus theta, or 90 minus angle C, is talking about angle A. Therefore, sine 90 minus theta is sine A, or cosine C. The first part of this problem asks us to find sine 90 minus theta, which we know is equal to cosine theta. However, cosine is adjacent over hypotenuse, and we do not yet know what the adjacent side of theta is. So we use the Pythagorean theorem. 5 squared plus b squared equals 13 squared. 5 squared is 25, and 13 squared is 169. We subtract 25 on both sides, giving us b squared equals 144. We need to square root both sides to get b by itself, and we get b equals 12. So cosine of theta is 12 over 13. To find cosine 90 minus theta, we know that this equals sine theta. And sine of theta is just opposite over hypotenuse, which is in this problem, we are to find side F. We are given 25 degrees and side F is opposite of our angle. We are also given the hypotenuse. The trig function that uses opposite and hypotenuse is sine. So we will use 7 of our angle, which is 25, equal to the opposite side, F, over our hypotenuse, which is 7. To get F by itself, we multiply both sides by 7. 7 over 7 equals 1, giving us 7 sine 25 equals F. When we plug 7 times sine 25, close our parentheses in the calculator, for this problem, we are to find angle P. Remember, anytime you are trying to find the angle of a triangle, we are going to use inverse trig function. We are given the opposite side of angle P and the hypotenuse. The trig function that uses opposite and hypotenuse is sine. So we're going to do sine of P equals 13 over 40. Because we cannot divide by a trig function, again we should use the inverse of sine. So in your calculator, we press second sine 13 division sine 40, close our parentheses, and we get P equals. In this problem, we are to find the hypotenuse of the triangle. We are given angle 85, and 43 is adjacent to angle 85. Since we are looking for the hypotenuse and we are given the adjacent side of our angle, cosine would be the trig function we should use because it's adjacent over hypotenuse. So cosine of our angle, which is 85, is equal to the adjacent side 43 over the hypotenuse m. Cosine 85 and m just switched because if we multiply m on both sides, we get m cosine 85 equals 43. Then we divide cosine 85 on both sides and we are given m equals 43 over cosine 85. When we plug this in the calculator, we get 43 division sign cosine 85, close our parentheses, and m equals 400. In this problem, we are going to use trigonometric ratios to find angle S. We are given 17, which is on the opposite side of angle S. We are also given 32, which is our hypotenuse because it is directly across from our right angle. The trig function that uses opposite and hypotenuse is sine. So we use sine of S equals the proportion 17 over 32. We cannot divide by trig function, so we have to take the inverse of sine, 17 over 32. When we plug this in our calculator, we press second sine 17 divided by 32, close our parentheses, and we get S equals 32. For two angles to be complementary, in this problem we are given a right triangle. Angle J and K are complementary, meaning that they cannot be our right angle. So we draw our triangle and label J and K, and then we are also given that tangent J is 15 over 8. Tangent is opposite over adjacent, so we label 15 on the opposite side of J, and then 8 the side that's next to or adjacent to angle J. Then we need to find sine of J, but sine uses opposite over hypotenuse. We are not given the hypotenuse of our right triangle, so this is what we need to find using the Pythagorean theorem. So we do 8 squared plus 15 squared equals c squared. 8 squared and 15 squared add together to get 289, and then you square root both sides to get 17 for your hypotenuse. So to find sine J, you take the opposite side of J, which is 15. In this problem, we need to find the area of the triangle that's given. The area of a triangle is 1/2 base times height. We are given the height, but we are not given the base. So we will use trigonometric functions in order to find our base. The base is on the opposite side of the angle given, and the height is the adjacent side. The trig function that uses opposite and adjacent is tangent. So we take this and we substitute tangent 7D equals x, which is our base, over our height, which is 6. To get x by itself, we multiply both sides by 6, and then in the calculator, we plug 6 tangent 70, close our parentheses, and get 16.484. However, we are not done. The problem asks for us to find the area of the triangle. So we substitute what we got for our base into the equation, and you get 1/2 your base, which is 16.484, times the height, which is 6, and the area of triangle. In this problem, we are told that a road ascends a hill at an angle of 6 degrees. We draw a right triangle using the hypotenuse as the road and then 6 degrees being the angle of how much the road is actually going up. V is on the opposite side of the triangle as our angle that we're given, and then 120, which is how many feet the road is going to be our hypotenuse. So we're given the opposite side and the hypotenuse of a triangle. So the trig function that uses opposite and hypotenuse is sine. So we take sine of our angle, which is 6, equal to the opposite side, which is what we're looking for, which is V, over our hypotenuse, which is 120. Then we solve for V by multiplying both sides of our equation by 120. For this problem, we are given all sides of our triangle. So to find sine of A, we find the opposite side of A, which would be 8, and our hypotenuse, which is For this problem, we are told that cosine A is 9 over 12. For this problem, we are told that cosine A is 9 over 12. So the first step would be drawing a triangle. Label one of your angles that is not your right angle, A, and then cosine is adjacent over hypotenuse. So label 9 for the side that's adjacent or next to A, and then 12 for your hypotenuse. Then we are asked to find sine of A. Sine is opposite over hypotenuse. However, we do not know what the opposite side of our triangle is, so we must use the Pythagorean theorem to find out what our opposite side is. So 9 squared plus b squared equals 12 squared. 9 squared is 81 and 12 squared is 144. We subtract 81 on both sides and get b squared equals 63. Square root both sides to get b by itself, and we get b equals 7.94. So sine of A is the opposite side, which is 7.94. The first step in this problem is to draw your right angle. Label your acute angles A and B, which are the two angles that are not your 90-degree angle. We are told that sine B is 6 over 20. Sine is the opposite over hypotenuse, so we label the side that's opposite of B 6 and our hypotenuse, which is always opposite of our right angle, 20. Then we are told to find cosine of A. Cosine is adjacent over hypotenuse. So we take our adjacent side of A, which is 6, and put it over. For this problem, we are trying to find an angle of a triangle, meaning we will have to use inverse trig functions. We are given the side adjacent or next to our angle as well as the hypotenuse. Which trig function uses both adjacent and hypotenuse? Cosine. So we take the cosine of our angle and set it equal to our adjacent side, which is 13, over the hypotenuse, which is 20. Then to get x by itself, we use the inverse of cosine and get x equals cosine to the negative 1, so second cosine 13 divided by 20, and in this problem we are given an angle. We are given the side that's adjacent to our angle or next to our angle, and then we are trying to find the side that is opposite of our angle. The trig function that uses opposite and adjacent is tangent. So we take tangent of our angle, which is 24, and set it equal to the opposite side, which is x, over the adjacent side, which is 12. So we get tangent 24 equals x over 12. Then we multiply 12 on both sides, and we get 12 tangent 24 equals x. For this problem, you were given that tangent B is 19 over 11. All they ask is that you find out what the measure of angle B is. B is an angle, so we just take the inverse of tangent in order to find what angle B is. So we get B equals second tangent 19 divided. The first step for solving this problem is to draw a diagram. Draw your house, the ground, and the ladder. We know that the house and the ground make a 90-degree angle. We are told that the ladder is leaning against a house so that the top of the ladder is 18 feet above the ground. So the side that goes directly straight up along the side of the house is going to be 18. We are also told that the angle that the ground makes with the ladder is 47 degrees. So where the ladder and the ground meet, we label that 47 degrees. Then we are told to find how far the base of the ladder is from the house. So our ground will be x. 18 is opposite of our angle. The ground is adjacent to our angle. So the trig function that uses opposite and adjacent is tangent. So we take tangent of our angle, which is 47, and set it equal to the opposite side, which is 18, over the adjacent side, which is x. When we multiply x on both sides and then divide by tangent 47, we end up just switching tangent 47 and x to get x equals